Alright, so this here is a calculus 2 problem that involves integrals, but it's a word problem, and from the word problem, you have to be able to discern how to set up the integral. A 2,000-liter cistern is empty when water begins flowing into it at a rate given by q prime of t equals 5 plus 10 e to the negative power of 0.01 t, where t is measured in minutes. We need to find A, how much water flows into the cistern in the first hour. We need to find B, find the function that gives this amount of water in the tank at any time t is greater than or equal to 0. This should be a function with the variable t in it. And then we need to find C, when will the tank be full? So if you don't know what a cistern is, which I didn't, it's like a cylindrical well. So hopefully that can help you picture it more. Alright, so let's get started with part A. So how much water flows into the cistern in the first hour? Well, the first step is to identify what we're given. We're being asked how much water flows into the cistern in the first hour. And we know that 1 hour is equal to 60 minutes. Now that we've identified that 1 hour is equal to 60 minutes, we can go ahead with the setup of our integral. So it's going to be a definite integral. Word. So we got the definite integral from 0 to 60 of q prime of t. Now, how much water flows in during the first hour? The formula that we're going to use here is the definition of accumulation. The total water from t equals a to t equals b is equal to the definite integral from a to b of q prime t. All right, we got the definition of accumulation right here, and let's do a side by side with this here and this here. Okay, here A is 0. Now that's going to be the start time, and B is equal to 60. That's because we've identified that 1 hour is equal to 60 minutes. Now the question is, what is Q prime of T? Well, Q prime of T is given to us right here. 5 plus 10e to the power of negative 0.01 t. Let's go ahead and write that out. Now really what we're doing is we're just bringing this down, but instead of writing q prime of t, we're going to write the function. Cool, so this is the setup of our integral. And what we got to do now is integrate it piece by piece. We're going to do this using the laws of integration. Now just like taking derivatives, we're going to integrate term by term. It's the first term here that we want to integrate. Let's do 5. How can we integrate 5? So at this point in time, since we're taking the integral of 5, which is a constant, we're going to apply the constant rule for integration. This here is the constant rule for integration, not to be confused with the constant rule for derivatives. Now, I mentioned earlier that these two are inversely related. The act of taking the integral of something is also known as anti-differentiation. In other words, you're undoing the derivative. Might I suggest doing side by sides of the rules for taking the derivative and the rules for taking the integral of something? Because if you write out the constant rule for derivatives and then next to it you write out the constant rule for integrals, it might be easier for you to understand the nature of the relationship between the integral and the derivative. Now, applying the constant rule for integration, we'll come to find that the integral of 5 is going to be 5t. Now let's see how we can take the integral of 10e raised to the power of negative 0.01 t. What's the rule that needs to be applied? Well, it's an integration rule. Moreover, it's an integration rule that involves taking the integral of Euler's number raised to a power times a variable specifically. Now, this is a bit of a rattlesnake, but you'll find that it's very prevalent in these types of problems. So if you can try to memorize this, you're good to go. All right, so let's take a look at this K here. Here for us, it's going to be negative 0.01. So we got the integral of 10 times Euler's number raised to the negative exponent 0.01 times t. It's going to equal 10 over negative 0.01 times e raised to the negative exponent 0.01. Yo, I'm editing and I just realized that there's supposed to be a t in this negative exponent here. Watch my cursor. There's supposed to be a t right here. So just pretend there's a t right there. Thanks. Now I'm gonna keep it 100 with you guys. I don't know how to take 10 and divide it by negative 0.01, so we're gonna use this calculator. We got 10 divided by negative 0.01, negative 1,000. Allow me to move this over here. So now what we'll do is we'll take this first term and we're gonna put it with this second term. And this here is what we're left with. To reiterate, what this is it's the integral of 5 plus 10 times e raised to the negative exponent 0.01 t. However, this is a definite integral, so we need to apply the fundamental theorem of calculus. But we need room. Alright, so for simplification, we just took the integral of this here, and this is our result. But this is a definite integral. So what we need to do is apply the fundamental theorem of calculus and apply the bounds of integration. Alright, so according to this here written in blue, there's two parts. We need to do f of 60 and f of 0 because the lower bound is 0 and the upper bound is 60. This is a bullet point, by the way. Now all we're doing is plugging in our bounds of integration of this function here, wherever t is 5 times 60 is 300. 1000 e is going to stay as 1000 e. Negative 0.01 times 60. So the exponent attached to the base 1000 times e is going to be negative 0.6. Right, so this up here is the upper bound. Let's do that lower bound. 5 times 0 is 0, and then that negative exponent, negative 0.01 times 0, it's going to go to 0. That means that e is going to go to 1, so it's just going to be negative 1000. This here is the setup via the fundamental theorem of calculus, but we need room. Alright, now we're going to simplify. These are like terms. This is our answer to part A. Or in other words, this is the liters of water in the first hour. B directs us to find the function that gives us this amount of water in the tank at any time. In other words, we're looking for a function for the amount of water in the tank. Here, we want q of x. Not q prime of x, but q of x. To find q of x, we need to break out a formula. Okay, so instead of q of x, we did q of t, and we have q of t equals the definite integral from 0 to t of q prime of u. From before, we know what the antiderivative is. Okay, so from before, we're already knowing what the antiderivative is. So q of t equals f of t minus f of 0. Now f of t equals 5t minus 1000 times Euler's number raised to the power of negative 0.01 times t. Great. And f of 0 is going to be negative 1,000. Okay, so then what's up with q of t? All right, so then q of t is going to be 5t minus 1,000 times Euler's number raised to the power of negative 0.01 times t minus negative 1,000. But we got to simplify this. Now, how do we simplify this? Well, we can take one look at this minus negative 1,000 and come to the conclusion that it's just going to be plus 1,000. So then this is going to be our answer for part B. Q of t equals 5t minus 1,000 times Euler's number raised to the power of negative 0.01 times t, and then this is going to be added to 1,000. Now we're going to do part C. The cistern is 2,000 liters, so the tank is full when Q of t equals 2,000. Now what we're going to want to do is write down Q of t, and we already found Q of t. Remember, it's 5t minus 1,000 times Euler's number raised to the power of negative 0.01 times t plus 1,000. What this formula tells us is how many liters are in the cistern at the time t minutes. So what we'll do is we'll plug in the full tank condition, and the full tank condition means that it's 2,000 liters. So 2,000 equals 5t minus 1,000 times Euler's number raised to negative 0.01 times t plus 1,000. All right, so let's check this out. What we should do is subtract 1,000 from both sides because we want to start isolating the terms with t. We'll rearrange to isolate the linear term, which is 5t. We'll add 1,000 times Euler's number raised to the power of negative 0.01 times t to both sides. This is now an equation where t appears in two different places, and it's called a transcendental equation. Um, Transcendental equations cannot be solved with basic algebra only. However, if you give me some room here, we can divide both sides by 5. And then upon simplifying the fractions, we'll find that it's going to give us t equals 200 plus 200 times Euler's number raised to negative 0.01 times t. At this point in my life, I do not know how to solve this type of problem without a calculator yet, but I do know how to solve it with a calculator. So let me show you how. Okay, you got your TI-84 and you're gonna press math. Then you're gonna scroll down. You see where it says numeric solver? See numeric solver. It's the one on the bottom. You're gonna hit that. Equation 1 is gonna be x minus left parenthesis 200 plus 200 times Euler's number raised to the exponent negative 0.01 times x, and then you're gonna put a right parenthesis. Now that's what that's gonna look like up top. Equation 2, you're just gonna put a 0. You can hit OK, and then whatever x is equal to is gonna be the answer. Thank you for watching.